Log properties are very closely related to your exponential properties. They just look and work a little bit different. Okay. So logs and exponents have corresponding properties. That's the main thing here. When we're talking about logs, we have three types of logs. We have logs with any base, and their inverse is when you have x equals b to the y. So your base to the solution. We have natural log. Natural log means that you had log base e. Instead of writing log base e of x, we write it as ln of x, natural log of x, okay? Natural log of x, because it stands for log base e of x, that's why when you write the inverse, it's x equals e to the y. Then we have common log. Common log means that your log has a base of 10. So when you write its inverse, the exponential, it's going to be x equals 10 to the y. Okay, do we see the connections, the patterns? Something helping you click? Okay, so what we're going to do is we're going to just make sure that we have a good understanding of going between logs and exponentials. So we're going to practice converting. So you see up here, we have log base 4 of 16 equals 2. And we're going to write that as an exponential. The exponential tells us that we're taking whatever the base is and raising it to the solution. And then our now output is going to be the argument. So we have 4 squared equals 16. So I took it from a log to an exponential. We see it? And that's true, correct? 4 squared is 16. So when there's just variables, it's the same thing. So you're taking your base, raising it to your solution, and your output is now your argument. So we have b raised to 5 equals 7. Okay. Now, remember when you see natural log means that you have log base e of that. So natural log of c equals 3 means that I have natural log base e, c equals 3. So again, I'm taking my base, which is e. I'm raising it to my solution, which is 3. And it's going to equal my argument, which is c. How we feel? How we feel? Good? Doable. You're literally
For real?
the whole human behind you, bro. All right. Now, let's keep going. Now, can we reverse it? Can I go from exponential to a log? Okay. So now that means, again, your input and your output are doing what? Switching. They're switching roles and responsibility. All right. The base of your exponential is going to be the base of your log. So my base is 2. What was your output is now your input. And your power is now your solution. And that's your log model. How it feel? Okay, let's try it again. So now we have 10. So 10 is our base. So we have log base 10. What was our output is now our input, our argument. And our power is our solution. Okay. This one can also be written without because it's a 10, I could just write log of 1. Does that make sense? Because the base is 10 and it's the common log and it's not required. Okay. Here we have e to the a equals 12. So our base is e. So we have log base e. Our output becomes our input. And our power is our solution. Log base e becomes what? Natural log. It becomes ln of 12 equals a. All right. Good? You feel good going between the two? All right, let's keep it rolling. Now we're going to talk about simplifying log expressions. In order to simplify log expressions, we have to use our log properties. Just like there are exponent rules, there are log properties that allow us to simplify, okay? When we are simplifying, we're saying, how can I make this as small as possible, right? All right. So the first properties that we're going to look at here are our inverse properties, essentially. So these are, we're going to call our inverse properties. So we have inverse property 1. Inverse property 1 applies to when you have an exponent, when you have a log raised to an exponent and the bases are the same, they're going to cancel each other out. And it's just going to equal m because they are inverses of each other. If you have a log and the base of the log and the base of the argument are the same, guess what they're going to do? Cancel each other out. And it's just going to equal m. When we say cancel, that means that they equal 1. Does that make sense? And it becomes cast with a friendly ghost. Because is it necessarily to write times 1? It is necessary to write times 1? It is not at all. Okay, so our inverse properties are saying that if I substitute this into the other function, it's going to always come out to be itself, x, x, x. That's why your output is the same. So looking at here, we have 5 log base 5 of 18. Well, this is property number 1. The base of my log, the base of my exponent are the same, so they become cast with a friendly 1, and the answer is just 18. Okay, log base 3 here. This is an example of property number 2. The base of the log and the base of the argument are the same. So, and you're just going to be left with the power, which is x minus 2. How do we feel about property 1 and property 2? Good? All right. Do you think that's going to change just because I have natural log? No, still the inverse. I have natural log, I have e. Anytime these two are next to each other, that is the inverse property. This is an example of property number 2. But as a natural log, and they're next to each other. So cast with a friendly 1, and I'm left with 3t. Number 4, this is an example of property number 1. I have an exponent, and it has the same base as its power. Even though it says ln, their bases are the same because ln means you have a log base e. All right, it was just too many letters to all have written next to each other. So instead of writing loge everywhere, they just write ln. Okay, cast for the friendly 1, and we're just left with t squared. How do you feel about the inverse properties? Good? Remember, all we're looking for, same base. Same base, same base. Questions, comments before I move on to property number 3?
What do you buy? This is Cadet Carter from Delta Company, GRT.
Okay, so our next properties are very similar to our exponential properties. So this one is first is our product property for log. Okay, so we're on our product property. Got weird there, but you get it. Product property is saying is that if you have two factors within your argument or multiple factors within your argument, you can separate them into their separate logs by adding them together. This is useful when you're trying to separate a number from a variable, right? So if you look here, there's two ways. You're either expanding or you are condensing. In this case, we were going to expand first. So I have two factors, 5 and x. Those are two things that are being multiplied. So when I expand them, it becomes log base 4 of 5 plus log base 4 of x. And that's how you use the product of logs property. Okay. Now, to condense. If I see that two logs with the same base are being added together, I can take their arguments and multiply them. So my base is the same. We have log base 2. And we have 6 times 10. So my simplified answer would be log base 2 of 60. Product property. How to fill out the product property. What comes after product? Anyone take a stab? Division, which is called the quotient property, which is similar to the quotient property for this guy. All right. So it doesn't matter if it's natural log or log, it still applies to the rule because they're all logs, right? The quotient property is saying if you have division, a numerator and a denominator in your argument, you can split them into two terms. The numerator is going to always be what you are subtracting, and the denominator is going to always be subtracting from. And the denominator is going to be your subtraction. I can't remember the terms for subtraction off the top of my head. It's like subtrahend and something else, but I can't think of it right now. Easy enough. So right here, my numerator is my first term. My denominator is my second term. Does that make sense? So we have the natural log of 6 minus the natural log of x. And now my variable is separated and I can start working to isolate it. Now, condensing. Condensing means I say, oh man, the bases are the same. In order to condense, because it's subtraction, I can now write this as a division problem. So we have natural log of 50 divided by 25. What is 50 divided by 25? 2. So the simplified answer would be the natural log of 2. Oh. Either way. The rule applies. Or change it to match it. I thought I switched it. Questions on quotient property? If there's division in my argument, it's going to lead to subtraction of the argument. All right, last is our power property. Uh-oh. So we have our power property. Our power property we've been using very, very easily, right? Power property is saying that the power of your argument is equivalent to being the coefficient of your log. Okay. And vice versa. Your coefficient can become your power. Okay. So in this case, we're expanding. So our power is becoming our coefficient. So that gives us 3 log of x. On here, we're going to condense, which means we're going to take our coefficient and it's going to become our power. So we get log base 2 of 3 squared. And what is 3 squared? 9. So log base 2 of 9 would be the simplified form. All right, those are our log properties. Are you going to be using them individually all the time? No. So we're going to look at examples where you have multiples. Yours should be correctly numbered as 11 and 12. Mine are not, because when I copy it, it's a weird thing. But now they are. All right, so we're going to go through the steps of doing simplifying. We're going to do number 1 together, and you're going to do number 11 together, and you're going to do number 12 in your group. All right. When you're condensing, you're going to always start with with the power property. So the first thing we're going to do is use the power property. Using the power property means that if there's a coefficient, it's going to become our power of our argument. So we would have log base b of q to the 3 plus log base b to the 6. Second thing you're going to do is you're going to decide, are you adding or subtracting? Because adding or subtraction is going to determine whether you are multiplying or dividing. In this case, we are adding, so we're going to be multiplying. So I'm going to be multiplying my arguments together. And my base is going to stay the same. So we have log base b, and we have q to the 3rd times v to the 6th. I don't know the value of anything, so guess what? That is all I can do. All right, your turn. All right, so let's talk about it. So step 1 is we're going to start with the property, power property. So we're going to take all of our coefficients and turn them into, so we end up with log of x to the 4th minus log of x plus 2 to the 6th. Step 2 is to decide, are you adding or subtracting? And we are subtracting, so that's going to lead us to division. Okay? As division, you're just dividing the arguments. So you're going to have 1 base. I don't need to write anything because it's common log, so it's 10 automatically there. Your first term is in the numerator, and what's being subtracted is in the denominator. And that is all you had to do. Us expanding wouldn't allow for us to simplify. All right. Questions, comments, concerns? So with our log properties, that means it allows for us to have room to manipulate, to make things look and be what we need it to be. Does that make sense? So we have our quotient and our division rule. And if it asks me to rewrite or rework the following ones so that they would all have a combination of natural log of 2 and natural log of 3, I would be using those two rules to make it possible. Okay. If I have the natural log of 12, I either can split it into a division problem or a multiplication problem. Does that make sense? Something that's going to produce so that I have natural log of 2 and natural log of 3. So this is going to be like a little brain exercise, let's see what your group can come up with. But you only can use natural log of 2 and natural log of 3, and you're going to rewrite L of 12 using the 5 properties we just went over. So you're using L of 2, natural log, I said L of 2, natural log of 2, and natural log of 3 to see how can you transform 12. Think of what are the factors of 12. All right. You can take a gander at A. How did we do? Remember I said, think about what multiplies. Okay. So I ended up using the product, right? And product and the power properties. Math is a bunch of puzzles. It's a game of puzzles. Okay. So on B, what operation am I doing? What's happening with B? Nobody can tell me what operation is happening with B. Quotient. There we go. Property. Quotient property. Quotient property tells me that I am subtracting the log of my numerator minus the log of my denominator. So this becomes ln of 3 minus ln of 4. It only wants me to have ln of 2 and ln of 3. So what do I need to do? Start with this guy. It's not a 2, is it? So how can I change 4 so that it is a base of 2? Four is 2 to the squared. So this becomes natural log of 3 minus natural log of 2 squared. The power property tells me that this 2 can now become my coefficient. So we have natural log of 3 minus 2 natural log of 2. And this would be the equivalent form of natural log of 3 divided by 4. Questions, comments, concerns? All right, on C, I'm going to give myself some room. On C, what property is it? Quotient or product? Quotient or product? Product. This product, I have 8 times the square root of 3. Because it's product, it can become natural log of 8 plus natural log of square root of 3. Okay, I'm going to start easy by changing natural log of 8 to base of 2. Because I need it to be either here or here, and it's definitely going to be easier to make this a 2 instead of a 3. So 8 becomes what? 2 to the what? 2 to the third. Plus, I don't want the natural log of the square root of 3. I need the natural log of just 3. What is another way that I can write square root? What is another way that I can write so that you know mathematically you're taking the square root? Okay, a square root is the opposite of a square, right? So therefore, you're going to reciprocate to the second power. If I'm reciprocating to the second power, that means I'm flipping the numerator and denominator. So natural log of square root of 3 can be written as natural log of 3 to the 1/2. And those are equivalent, right? So now I can use the power property. The power property says that the powers of my argument become the coefficient of my log. The powers of my argument become the coefficient of my log. So we have 3 natural log of 2 plus 1/2 natural log of 3. So now I've written it in equivalent forms using only natural log of 2 and natural log of 3. Okay? Questions, comments, concerns? Remember, we're not just learning properties and doing nothing with them. We're going to use them. We're going to learn the properties and use them as many ways as possible. Oh, oh no. So let me get sick. Okay. All right. I think I give you enough time right now. On 14. On 14, in your groups, you're going to practice condensing. Okay. Step number 1 of condensing is that we apply the power product first. Then you're going to decide, are you adding or subtracting? Capiche? All right. So go, you're then going to check with your group mates. All right. So let's talk about what we got. So on the first one here, you should have, again, what property do we start off with? Power. So I should have moved 2 to the third, and that gave me natural log third to the 3 squared plus natural log of 7. Remember, if you're waiting for me to do something, you're not learning. You only learn when you try and make mistakes and correct those mistakes. But if you're leaving your page blank until Ms. Jones writes something, you're hurting yourself, not helping yourself. Okay? It's a harmless practice. Ain't nobody looking at your paper. Okay? 3 squared gives me 9. 9 plus natural log of 7. Now that I'm adding, what property am I using? Product. Product says that if the bases are the same, I can multiply the two together. So that gives me natural log of 9 times 7. What is 9 times 7? 63. There you go. Good job. Genius. Okay, on to the next. Again, we start with the power property. There's no power, there's no coefficient here. There is a coefficient here. So that 3 becomes the power of the 5. So we have log base 2 of 6 minus log base 2 of 5 to the third. We're subtracting. So subtraction tells us that we can make this down to 1 log because the bases are the same. In that 1 log, you're dividing. So your first term goes in your numerator. Your second term goes in your denominator. So we now have 6 divided by 5 to the third, which equals log base 2, 6 over 125. If you were completely wrong, do you see your error? Yeah. I just didn't want to write 125. So I'm like, where did that come from? It came from 5 to the third. All right. On our last one, we have -2 log base 3 of 5 plus 4. So that -2 is going to go to the 5. I just want to see if anyone, how do we do here? So you end up with log base 3, 5 to the -2 plus 4. Bless you, bless you. All right, so we have this plus 4 here. Oh no, the bases aren't the same. What do we do? Nothing. We're going to just stop here. My bases aren't the same. So I can simplify 5 to the -2. That'll become 1 over 25. But I can't combine these two. Does that make sense? Because the bases are not the same. Yeah. Now, if you want to like be extreme and make 4 into something else, you use the inverse property. Just for poops and giggle, I'm going to show you what that would look like. So if I wanted the bases to be the same, I would have to make this log base 3, and my argument would be 3 to the 4. Because I would be using the inverse property, which says that no matter how I write this, the answer is still going to just be what? 4. Does that make sense? So if you did that, kudos to you. If not, I'm glad if you got to this point. But if you chose to do that, now instead of just this is the substitution value for 4. So that means that this would equal 5 to the -2 times 3 to the 4. And whatever that comes out to be is what you get. And this could continue to keep going and being simplified. I should have left myself room. Hold on, I'm going to do it on here. All right, so what I was saying here on this one is that the bases aren't the same. So when we got down to log base 3 of 5 to the -2, 4 did not have a log base 3. So if you didn't want to challenge yourself, you would be using the inverse property. The inverse property, blue. The inverse property is saying that if I make the base of my log and the base of my argument the same, then the value is still going to be 4. Does that make sense? So this is still 4. Now that these are the same, I could combine them using the product rule. The product rule is saying that I have the same base, cool, and because my base is the same, I have 5 to the negative 2 times 3 to the 4th. So we'd have 5 to the negative 2 times 3 to the 4th, which is the same thing as log base 3 of 3 to the 4 over 5 squared. And we keep on doing the math of the math. This would give us 81 over 25. Okay? So I wanted to get down to that to show you what that would look like. So if we start off with log base 3, so I'm going to write that first, alpha window, log base 3, and I'm going to show you that they are equivalent forms. I forgot my 2, didn't I? My negative 2. Oh, where'd you come from? So I had negative 2 times, was it a 5? Yes. Plus 4. And that's what we got. Now, after we went through and simplified, alpha window, 5, we have 3 over 81 divided by 25. If I did it correct, these two answers should be the same. Hit enter. And what are they? They're the same because they're equivalent. Okay? And so this is an example of, yes, you can use that inverse property to manipulate. It's not going to change the value because it's just 1 in a costume. All right? The inverse property are just 1 in a costume. If you got to the log base 3 of 81 over 25, awesome. I'm super proud of you. If you only got to where you use the power property and you stop, good job. I understand why you did that. Okay. But the goal really would have been to get down to one singular log, which meant that we would have gotten down to this guy. And as you can see, they are equivalent. Got it? All right. So here is your group practice. In your group, you're going to determine if these are true or false statements. If it's false, you're going to tell me why. So did this person do it correct, basically? So you're checking someone's work. They wrote, this is their answer. Is their answer correct or is their answer wrong? This is where they started. This is their answer. Are they right or wrong? So you're determining if these people did the work right. All right. And go. All right, so we're gonna go through one by one to see why it or what it should be. All right, but before I'm gonna get the class response on which is which. All right, so starting here, where's my little pen? You see nothing. All right, on A, what did y'all think it was? Was it true or false? Were they right or wrong? We got what? We got 5 trues and 1 false. Okay, come back. On B, true or false? Ooh. I heard how many truths? Per group? We're doing it by group. Group 4 is true. And the rest are false. All right, on C. Group. We only got one group responding. False. Anyone else? All right, what about D? 3 groups say false. E. Anybody else? Okay. All right, so let's see. A, true. A is true. A is true. You would distribute the 5 to the x and the 5 to the 7. Because it's the power rule, our exponent power rule. So basically, I did 5/7. Okay. All right. B. B was false. Instead of having the product in the middle, it should have had what? Plus. It had the product symbol instead of the plus sign symbol, which is why it should be false. All right, let's look at C. C was true.
One thing I didn't have to stress. One thing I didn't have to stress.
Remember the power? We do power first, and then you're going to work from left to right. So this is going to be divided by this and then multiplied by that. Or you could have multiplied and then divide. Because there's two symbols, which means that you're using quotient and product. It doesn't matter. It's still gonna, it does. So like if you did the quotient first, so you would end up with log base 6, and you would have x divided by 3, right? Times, and then your y would be next, right? Ah, if you work left to right, it should. Because these aren't connected in parentheses. You're only subtracting that one. I would agree with you. I'll give it to you. I'll give it to you. AP Classroom, we have a, so it should be xy over 3. Because you're dividing the 3, but you're subtracting the log base 3, but adding the y. So this should be false. AP Classroom is wrong. This came from AP Classroom.
Wait, so C is wrong?
Huh? You're supposed to be work from left to right.
Oh, right. Like I would not even like that. Erase all my audio.
I'm like, I don't know what that is.
All right. That sounds like something that needs to go on the brag board.
Yeah, I'll do that.
All right. D. It's false. It is not the correct use of the product rule, right? The logs have to be adding together, not the argument. All right, on E. On E, you're working from top to bottom. So on the top, you have log of 10, log base 10, and you have x to the 5th times y squared minus the bottom, which is log base 10 of 10. And then you would keep separating. This is going to separate through product and then by power, right? So product means I'm going to take, separate, and become 2 logs. Boom, boom, boom. And then I'm going to use power. And power is telling me that my powers become my coefficients. And this is your inverse rule. And inverse tells me that the base and the argument are the same. So it's a 1. So your final answer would be that. Because it had a product symbol instead of an addition symbol. You're supposed to add them, not multiply them. You see it? All right. So the rest of the class, you're going to be working on your exit ticket. It is a self-check exit ticket, meaning that you're going to do the exit ticket on paper, but you're going to input your answers into into Canvas, and it'll tell you if you're right or wrong. Does that make sense? And that is what you're doing for the rest of the period. Any questions, comments, or concerns? I will be here after school.